In today's video on the circle, we're going to be looking at problem questions where we have the centre and a chord of the circle. And this is a little bit of a follow-on from the previous video where we had circles cutting off intercepts on the axes. So before we begin, just a couple of geometry rules to be aware of. So imagine that I have a circle, and here's its centre, and between these 2 points I have a chord of the circle. Well, if I draw a line from the centre of the circle to the chord, and if that line is perpendicular to the chord, it will cut the chord into 2 equal parts. And the point at which this line from the centre and the chord meet, marked in orange here, is the midpoint of the chord. This will be useful for us in solving problems because just like in some of the questions that we saw in the last video, it'll allow us to create right-angled triangles that we'll be able to solve using Pythagoras. Notice how the line that I've drawn in here in yellow is a radius of the circle. It's useful to note that this statement also works the other way around. So we can say that conversely, a line from the centre which bisects a chord is perpendicular to that chord. Okay, so here's an example first of all. So in this example we have a circle and we know its centre, and we also have a chord that we know the midpoint of. Centre is 2, 1, and the midpoint of the chord is 2 minus 2. And I also know the length of the chord. And now I want to find the circle's radius and equation. So the first thing I want to do is refer to this geometry rule up here. And I want to draw a line from the centre to the chord. And the line that I draw is going to be perpendicular to the chord. And don't forget, I know this because I know that a line that I draw from the centre to the midpoint of the chord will be perpendicular to the chord. So now as I continue to engage with the diagram, I see that I can draw in a radius. In fact, I have 2 options for where to put the radius. I can put it in this position, or I can put it here. Either is fine. You can do both if you like. And my next step now is going to be to find the sides of this triangle. Well, one of those sides is really easy to get because in the question it tells me that the chord has a length of 4. So the distance from this point to this point is 4. And since I know that I've bisected that, and that 2 minus 2 is its midpoint, that means that I know that this distance here is 2. So from this point to the midpoint of the chord is 2. I don't have direct knowledge of any of the measurements, but I can work them out quite easily. So I can find the length of this line from the centre very straightforwardly by using the distance formula on the 2 points that I know. So pause the video here for a moment and do that calculation using the distance formula and see what it comes out as. So in this case, that distance comes out as 3. And I'm filling that in again into my diagram. So I've got this distance 2, this distance 3, and now I can find the last side simply by using Pythagoras. So again, pause the video here and do that yourself. So of course, this missing side that I want is the radius. So I'll say r squared equals 2 squared plus 3 squared. So r squared equals 13 and r equals root 13. So the first part of the question is now complete. I've found the circle's radius. Now I must find its equation. So I'll be using this formula, which remember is on page 19 of your log tables. And I'll just make a note of my information before I substitute it in. So my centre is 2, 1 and my radius is root 13. And remember, of course, the centre gets labelled HK, and then I'll just substitute in to get the equation. I haven't been asked to write my answer in any particular format, so I'm quite happy to leave it pretty much like that. The only thing that I'll do really is just square that root 13 at the end. And there's my equation of the circle, x minus 2 squared plus y minus 1 squared equals to 13. Okay, so now a question for you. Okay, so here's your question. A circle has centre 0, 1 and the midpoint of a chord of length 4 root 5 is minus 1, 3. Find the length of the circle's radius and its equation. So in the diagram, I've got a centre marked in, and I've got a chord, and I've got the centre point or the midpoint of the chord marked. By the way, I'm giving you a diagram to go with this question, but you might not necessarily get one every single time. However, you should be able to create one yourself from the written information. And again, it's always a good plan for a question that involves a visual component to try and draw a sketch if at all possible. Okay, so again, we'll start by joining the centre to the midpoint of the chord. And since I know that this line is bisecting the chord, it must be at right angles to it. And I'll join up the centre with the end of the chord. Either end will do, it doesn't make a difference. And now I'll fill in whatever distances I can figure out. So the chord I've been told is 4 root 5. So the distance from this point to this point is 4 root 5. So I can divide that by 2 to get the side of the triangle. So 4 root 5 divided by 2 is just 2 root 5. So I've got that side to begin with. And I can, of course, calculate this side using my distance formula. I think I forgot to say pause while you're doing the questions, so if you haven't paused yet, do it now. And this distance comes out as root 5. And now, just like in the example, we want to find the radius, and that's the hypotenuse of this right angled triangle, so we can use Pythagoras for that. Again, it's the radius that I'm looking for. Do make sure to put a bracket around these guys when you're squaring them. It's not quite so crucial for the first one, but for the second one it's really important because you're squaring not just the root 5 but also the 2. So we get a value of 25 for r squared, and r squared is root 25, which works out nicely as 5. So now we've got the radius, that's that part done, and now we need to find the equation. So again, to find the equation of a circle I need to know the centre, and I have that at 0, 1, and I need the radius, and that's 5, and I'll just make a note of the formula as well. And then I'll note my 2 pieces of information, and I'll label my centre as HK, and then it's just simply a question of substituting in. And then just a little bit of tidying up needed. Do keep your eyes open in case they do ask you to write the question or the equation in a particular format from the question, but here I'm just being asked for the equation, so it's not too much required. I can leave in the 0 if I like, but I can equally drop it because it's not really doing anything. And of course I'll square the radius, I'll square the 5. So I'll end up with x squared plus y minus 1 squared equals 25.